Hi, this is Bryce Fudge, and this is going to be my video recording second part. So first, we're going to want to do make a problem similar to the first one in our review guide, and I chose y prime equals x plus y. So the first step when you're doing this is we want to get the x and y that we want for both areas. So let's do the first quadrant and second quadrant first, and we have to have 4 in each. So I'll take 1, 1, 1, 2, 2, 1, 2, 2 for one quadrant. And then for the next quadrant, I'll do -1, 1, -1, 2, -2, 1, and then -2, 2. And that's first two quadrants. Okay, then we're going to plug those into the equation to get what y prime is, and the y prime is also the slope. So 1 plus 1, when we plug it in, is 2, 3, 3, 4. This is 0. This is 1. This is -1. And this is 0 as well. So that's going to be for the first quadrant. And then for the second quadrant, let's make another one. For the second quadrant, we're going to do 1, -1, 1, -2, 2, -1, and 2, -2. And that's one quadrant. And then we're going to do -1, -1, -1, -2, -2, -1, and -2, -2. And that completes the third quadrant and fourth quadrant. And then when we combine these, it's going to be 0, -1, 1, 0, -2, -3, -3, and -4. And these are for the last two quadrants. Okay. Now we can make a graph really quickly. We'll have 2 in each, since we only used -1 and -2 for our x's and y's. Okay, so now what we're going to do is we're going to make our points for each quadrant. Okay, now for reference, our original line is going to look somewhat like this. Alright, so that's what our line for this looks like. and then we plug in our y primes for that point, and what we'll get is about this for each part. We'll get a line about this. These are all about the same, but slightly different. Where's quadrant 1? Right here. 2, 3, 3, and 4 for these. So they're all slightly different, but they're all positive. And then for the next quadrant, we have this one was 0. This one was 0. This one was positive. And this one was negative for these ones. 0, 1, -1, and 0. Alright, now for the last two, we have 0 again, 0 again, and then we have positive and negative once again, and they're pretty much mirrors of each other on each side. And these two are pretty much mirrors too, but they're opposites, so these ones are also all going to be negatives and slightly different on most of them. They're all going to be negative because 0, -1, 0, and 1 right here, and then -2, -3, -3, and -4 down here makes those all negative. And that should be the graph and point for each, and slope for each on number 1. And then for our second problem, we're going to copy or make a problem similar to 2b. And the problem I've chose for this one is x, y prime equals 2y x to the 4th. So first things first, let's turn this into terms of dy dx. So x dy x dy dx equals 2y x to the 4th. We won't touch that yet. Now let's transform this expression so we can move the dx to the other side. And this will become x dy equals 2y x to the 4th dx. And then let's divide by both sides by x. And that would make it dy equals 2y x to the 4th over x dx. Now after this part, let's take this y dy equals 2x to the 4th over x by taking that y out. 2x to the 4th x, and then we still leave that dx in. So now we know that over here we can put ln, and then we'll make it absolute value of y, plus c, and we all know that c ends up turning into 1, which cancels out, equals, and we'll also, let's actually take the integral of these while we're at it. Then we'll take the integral of the other side, and we'll have c over there too. So it'll be 2x to the 4th over x dx, and we won't add that yet. The C part I skipped a step on, but then the next part would be ln y. Then we'll have the C that we can cut out equals x to the 4th over 2 plus C, and the C state remains. Undo that, and then we would I'm just rewriting it without the C. X to the 4th over 2 plus C. Alright, and then after this, let us get rid of that ln by adding an e. So e would take away that ln right here, so we wouldn't have that anymore. And we'll just have absolute value of y equals e to the x 4th over 2. And we'll still have C over here. We'll still have C over here. And then for our final product, we can, or because this splits, this is supposed to be up here, plus C, but that can also turn into e to the C, and e to the C just becomes C, so that's where that comes from. So then we can just take the absolute value of y, so we can get rid of that, make it positive, and then it can turn into y equals e to the x to the 4 over 2 times C, and then we can just move that C in front to make it look a little nicer. So C and then e x to the 4th over 2. And that will be the final answer for that problem. So next, let's do 3b and make a similar problem to that from the test review. So we're going to be using 4 rectangles and for this one this is the Simpson rule problem. And the problem we'll be using that's similar is from 10 to 2 or 2 to 10 x to the 3rd dx. So our b in this equation, in this problem, is 10. Our a will be 2, and then our n we said was 4. Okay, so our delta x is going to be, the equation for that is b take away a over n. So in our case, we would have 10 take away 2 over 4, which equals 2. Then let's make a line graph right here. And we'll have 2, 4, 6, 8, and 10. In this. Alright, now the base equation 2, 4, 6, 8, and 10. Now the base equation for the Simpson's rule is S of n equals delta x over 3 bracket f of x 0 plus 4 f of x 1 plus 2 f of next would be 2 f of x 2, and then 4 again, f of x 3 plus 2 f of x and take away 2 plus 4 f of x and take away 1, and the final one is f of x n. For the first two, we don't have a 4 or 2, and inside it's interchanging. Okay, so our equation setup for this we have 4 rectangles, so we'll call it S4 equals 2, which we got from up here, over 3. And then we'll put the brackets, and we'll have f of 2 plus 4 f of 4 plus 2 f of 6 plus 4 f of 8 plus just f of 10 for this one, because we don't have it on the last or first. Alright, let's close off that bracket really quick. So now we're going to plug these in using our x to the third. So because f of x for this equals x to the third. So now when we're done plugging in using the calculator, we will get S4 equals 2/3 remains the same. And then inside we'll get 8 plus 4, 64 for this one when we plug it in. Then for the next part, we'll get plus 2 of 216. Then for the next part, we'll get 4 again of 512 when we cube that, plus 1000 as the last part. Alright, and then let's close off that bracket from the beginning. And then when you add all these up and plug them into a calculator, what we'll get is S of 4 equals 2,496, which will be our final answer for the Simpson rule on this problem. Alright, so the last problem I'm going to show was 11b, a replica of 11b, and for this one we're going to be using integration by parts. So the integration by parts formula is the integral of f of x g prime of x dx equals f of x g of x take away, then we take away the integral from f prime of x g of x dx. So the problem that we're going to use in this, the problem we're going to use for this is the integral x sine x dx. Okay, so for this one, we'll make our f of x equal to x. And then that would mean f prime of x equals 1, because that's the derivative of x. And then our g prime of x equals sine x, which would make our regular g of x, after taking the antiderivative, would be negative cosine of x. So now we plug these into the equation now that we have most of the parts for it. And what we get is, for the first step, is x sine x dx equals negative x cosine x plus the integral. Oh, for this part we would get first, I skipped a step because I combined them. Let me show you what that step was. So that step was, we first just have x, and then it's still negative cosine of x, and I combine those, but I'll do that in a later step. And then we take the integral from negative cosine x, and then we multiply that times 1, so it'll stay the same because f prime of x equals 1, and dx. Okay, now let's simplify this. And for this part, it remains the same. X equals, and then now we can combine this part and make it negative x cosine x plus the integral of cosine x dx. Alright, now this portion right here will turn into sine x. Yeah, this part will turn into sine x, and then after adding that in, that is still equals negative cosine of negative x cosine x. We've already finished that up top, and now let's just put that sine x in, and then we'll do plus c, and this will be our final product for this answer. Thank you.